Hello everyone, welcome to today's class. Let's continue with our topic trigonometric functions, and specifically we'll continue with the topic known as identities. So I've categorized identities in multiple parts which will make learning them slightly easier. Let's start. So the first identity is sine a plus b. Now sine a plus b is sine a cos b plus cos a sin b. Okay. Similarly, sine a minus b is sin a cos b minus cos a sin b. Now the format you need to remember to learn this identity is sine cos cos sine. Okay, sine cos cos sine. If identity is regarding plus, so plus. If identity is about minus, then minus. Okay. So formats makes things slightly easier. Okay. That is regarding sine. Next is cos a minus b. So the format for this is cos cos sin sin. So cos a cos b, sin a sin b. If there is negative in identity of a minus b, you change the sign. It is positive here. Similarly, cos a plus b. So again, format is cos cos. So cos a cos b, sin a sin b, and the identity is for plus. So put a sign of minus. So learning formats makes formula slightly easier here. Next, tan a plus b is tan a plus tan b upon 1 minus tan a tan b. Slightly weird format, but that's tan effectively. You have to learn the format as tan tan. Okay, and upon 1 tan tan. If it is plus here, put minus here. If it is minus here, put plus here. Like that. Tan a minus b is equal to tan a minus tan b upon denominator, change the sign, negative instead of negative put positive, 1 plus tan a tan b. Last, see, most important are these three. Cot is very specific and will be used in very specific question, very rare. So these three are must: sine, cos and tan. Cot the questions are very rare and the identity is also very typical here. Cot a plus b, it is cot b cot a minus 1 upon cot b plus cot a. If you look at the format of tan, it is opposite, pretty much opposite, but still a bit of variation is there. Cot a minus b is cot b cot a plus 1 upon cot b minus cot a. Okay, so these are pretty much your identities. Sine a plus b is sine cos cos sine. Okay, if it is plus, put plus. If it is minus, put minus. Cos a plus b or a minus b, cos cos sine sine. If it is minus, put plus. If it is plus, put minus. Tan a plus b, the format is tan tan upon 1 tan tan. Okay, so if it is plus, put plus, and in the denominator change the sign. If it is minus, put minus, change the sign in the denominator. Cot is very rare, so don't focus too much on this. Only majorly focus on these. Okay. All right. Now let's learn how to apply it. Okay. First question. You need to find sine 75. Now we can find 75 as well as 15-degree angles using these identities. See, let's break it down. I can write 75 as 30 degree plus 45 degree. Okay. Now consider this as your A, this as your B. Now the formula is sin A cos B plus cos A sin B. Okay. Put the values. So sin 30 cos 45 plus cos 30 sin 45 and solve it. So sin 30 is 1 by 2, cos 45 1 by root 2, cos 30 root 3 by 2, sin 45 again 1 by root 2. So the denominator effectively is 2 root 2. In the numerator it is root 3 plus 1 upon 2 root 2. That's the value of sin 75. Okay. Same way you can find cos 75 also. Okay. Second part, tan 15. Now 15 can be written as tan 45 minus 30. Okay. Basically we have to write in terms of the standard angles that we know. This is your A, that's your B. So that becomes, the formula is tan A, so tan 45 minus tan B, that's tan 30 upon 1 plus tan A tan B, B is 30. Just put down the values. Tan 45 is 1, 30 is 1 by root 3 upon 1 plus 1 into 1 by root 3. Solve this, you will get root 3 minus 1 upon root 3 plus 1. Okay. You can further rationalize it also. You can leave your answer here also. It depends on the question whether it is giving you answer in this format, or you can rationalize. So if you rationalize, you will get the value of 2 minus root 3. Okay. If you rationalize, otherwise this is, both are considered as the value of tan 15. Okay. So this is pretty much basic that we can use to find 15 degree angles and 75 degree angles of sine cos tan. Cot will also be found. Okay. All right, let's continue. Now the question will not always be regarding expansion of the formula. Sometimes it's about compression also. Now if you look at this question, although it's a proof question, but what they will give you is they'll give you this expression, and this will simplify to, and they'll give you 4 options. Out of this, one of the option will be this sin x plus y. So even while doing subjective question, try to think that the same question can be easily formulated to an objective question also. First of all, the first idea that comes into the mind of the student when they see this question is that this is a minus b, we can apply it. This is again a minus b, so we can expand. But the problem with the expansion is, like, each expansion gives you 2 terms in which there is product already, and then you have to multiply them. Okay, 2 terms in this, 2 terms in this, when you multiply you will get 4 terms. So number of terms are increasing, whereas the question, if you see, the question is asking you to prove it, and this is a very simplified term, so I'll not expand it. then what can we do? For the time being, what you can do is consider this whole pi by 4 minus x as your a, pi by 4 minus y as b. Okay, so this is again a, this is again b. If you read the question now, it is looking like cos a cos b minus sin a sin b. Now this is an identity. Cos cos, look at the format, cos cos, sin sin. So the format is applicable. So this is identity of nothing but cos of a, and because there is negative, so we have to change the sign, plus b. That means this question is actually nothing but cos pi by 4 minus x plus pi by 4 minus y. This question is purely of analytical sort. Once you analyze this, the question becomes very simple. Now add pi by 4 becomes pi by 2 minus x minus y. I can take negative common here. So if I take negative common, it becomes pi by 2 minus x plus y. Now what is pi by 2 basically? 90 degree. I told you to learn the standard angles. 90 degree. Cos 90 minus something, let's consider as theta. So use the conversion formulas. Cos 90 minus, if 90 is involved, we have to change. So cos will become sine, angle will remain same, x plus y. Now all we have to do is decide the quadrant. Pi by 2 minus. Pi by 2 minus means we are doing in first quadrant. First quadrant, everything is positive. So I think we are done. That's your RHS. So the question was not lengthy at all. Conceptual, yeah. All right. Same idea is used in the question number 3 also. Yeah. Same thing. Sine something, sine another something, sine sine. Okay. Sine sine. Then cos cos. So if try to read it from reverse, cos cos plus sine sine. So if this is a b and this is again a b, so this is nothing but cos of a minus b, cos cos plus sine sine. So we have to do cos a minus b. So that becomes cos of a. A is n plus 1 into x minus n plus 2 into another x. Now what is the subtraction of n plus 1 and n plus 2? That's minus x. And in cos, negative doesn't come out, it cancels. Cos of minus theta is cos theta. So I can rewrite this as cos x by, because cos of minus theta is equal to cos theta. I gave you these in the trigonometric conversions while we were doing for multiple angles. 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, and then there was minus theta concept also. Minus theta is in fourth quadrant. Fourth quadrant cos is positive, that's why this is cos theta. Okay. So just remember that in the cos, this negative has no effect. You can remove it effectively. All right. Next one, let's see. Fourth one. Okay. So there is an expansion here, pi by 4 plus x, pi by 4 minus x, and you have to get this. We have to prove that these two are equal actually. Anyways, suppose the question is like, for this, simplify this to get 4 options, and one of the option is this one. The first thing that we can do is just expand in the numerator. This is a, this is b, so a plus b. In the denominator it is a minus b. So just use the formula for expansion. So tan A plus B. So tan A plus tan B upon 1 minus tan A tan B. Okay. Upon, in the denominator we have to do A minus B. So tan A minus tan B minus tan B upon 1 plus tan A tan B. Now pi by 4, first of all, what is pi by 4? 45 degree. And what is tan 45? 1. So just put down the value here. So tan pi by 4 is 1 plus tan x upon 1 minus 1 into tan x upon denominator is 1 minus tan x upon 1 plus tan x. So just take the denominator up and reciprocal. So you'll get 1 plus tan x upon 1 minus tan x, and the denominator will reverse. So 1 plus tan x in numerator upon 1 minus tan x. That's nothing but same thing written twice. So 1 plus tan x upon 1 minus tan x whole square. Okay. This particular expression 1 plus tan x 1 minus tan x. Now as such the question was not difficult, all it required expansion, but there is something important that I want you to remember for future references when it will be used, wherever it will be used. Tan pi by 4 plus x is 1 plus tan x upon 1 minus tan x. Now remember this both ways. Okay. More importantly, reverse one, because when this expression will come and I'll ask you to convert this into a single tan, you might not be able to recall that this was an identity. So learn this. It will be used in the later stage. When I want to convert this expression into a single tan, this is it. And similarly, tan pi by 4 minus x is 1 minus tan x upon 1 plus tan x. This one also. Both ways, and more importantly in reverse. Okay, this will be helpful later. All right, now one very particular kind of question, very interesting kind of question in fact, is this one of a unique kind of question which makes Trigo actually difficult. This is question number 5. Now he is asking you to prove tan 3x, tan 2x, tan x is equal to tan 3x minus tan 2x minus tan x. It means the product has somehow become the difference. Now we haven't studied multiple angle 2x, 3x. We have not talked about those. And even if I gave you the formulas, the idea is that the formula for tan 2x and tan 3x will be very complicated. Okay. Once you multiply a complicated expression with another complicated expression, it will complicate things. It will not simplify anyhow. So expansion is not the idea for this question. Okay. So very unique idea, that is, I can write tan 3x is equal to tan 2x plus x. I've broken down this 3x as 2x plus x, and I apply the property of tan A plus tan B. So it becomes tan A tan B upon 1 minus tan A tan and I cross multiply this expression here. So that becomes tan 3x minus tan 3x, tan 2x, tan x. I multiplied with both is equal to tan 2x plus tan x. And I take this expression on the left and I take this expression on the right. That's it. So that left side becomes tan 3x minus tan 2x minus tan x is equal to, and right side becomes tan 3x, tan 2x, tan x. Okay. Hence it is proved. So not every single question of trigonometric identity comes from like LHS, RHS. Sometimes the idea is slightly different. So the key step for this question was this first step. Okay. All right. Same idea here also. Question number 6. Exactly same idea. Instead of tan, now you have to use cot. This is cot x cot 2x minus cot 2x cot x minus cot 3x cot x is equal to 1. Okay. Now this can easily be formulated in a objective question. Okay. Now same idea. I will write cot 3x is equal to cot 2x plus x and use the expansion cot b cot a minus 1 upon cot b plus cot a, and just cross multiply this. So this becomes cot 3x cot 2x plus cot 3x cot x is equal to cot 2x cot x minus 1. Take minus 1 on this side, take this whole expression on this side. So 1 will be equal to cot 2x cot x minus cot 2x cot 3x minus cot 3x cot x. Pretty much the same expression. Okay. This can easily be formulated in an MCQ. They will give you like not equals to, they will give you like 4 options, na? A, B, C, D, 0, 1, 2, 3, or none of these like this. Okay. 4 options given and you have to select any one of it. Okay. This is the proper way to do it. There's a way to cheat also. Smart cheating, it's called smart cheating, not exactly a cheating. And the problem is with that kind of approach, you have, the question is very has to be in a very specific manner. Okay. So idea is like if some expression of x is equal to a constant value, that means that particular expression is an identity, and identity is always true for any value of x. I'll repeat the idea first of all. If a question is given in terms of x or any variable and the value is a constant, means it's not depending on x, that means it's an identity, that means it is true for any value of x. If it is true for any value of x, what you can do is, don't solve it. Okay, what you can do is put any value of x, put x is equal to let's say 30 degree, 45 degree, anything you can put. Just make sure that the expression is not invalid. Okay, you could put 90 also. You can put 0 you cannot put because cot 0 is undefined. Okay, So you can put 90 degree also if you want, 45 degree if you want in this expression, and you can get the same answer as 1. But remember that this is only applicable if the options are given like this, a constant values. If the option is in terms of, let's say, sine x plus y or tan x plus y, something like that, then you cannot use that. That's why standard approach is pretty much safe always, but this has their own risk. And also remember, you cannot put 0, because make sure the expression is not becoming undefined. So same question can be done by putting the value also, you can get the value. All right, few more applications, few more questions. Sixth done, let's do seventh. Okay, so this is the expression and you have to get the value of it. Okay, the question was incomplete, you have to get the value of it. So you have to solve and get the value. Now how can you do? The idea is always very simple. The question, if you look at this question, first of all, it has symmetry in it. A minus b, b minus c, c minus a. Denominator is b, c, c, a, b. Okay. So for the starters, LCM should not be a good idea here. The easiest idea is looking like this: b minus c, c minus a minus b. Let's expand. Okay. So sine b sine cos minus cos sine upon cos b cos c upon cos b cos c. I'm making the denominator also into two parts. Why? Because few expressions are matching in numerator and denominator. That's why I'm splitting the denominator. Same thing, do it with this: sine cos minus cos sine upon cos c cos a upon cos c cos a. Okay. Third expression I'll write below: sine a cos b minus cos a sine b. Denominator I'll split again: cos a cos b cos a cos b. Few expressions are cancelling. Cos c cancels, cos b cancels, cos a cancels, cos c cancels, cos b cos a. What you are left with is sine by cos tan b, sine by cos tan c, sine by cos tan c, sine by cos tan a, sine by cos tan a minus sine by cos tan b. Again, I think pretty much this is done. Tan b cancels tan b, tan a cancels tan a, tan c cancels tan c. So this is 0. So the answer is 0. Usually these kinds of symmetrical expressions, whenever the questions ask, majoritively the answer is always 0 or 1. Okay. All right. Let's look at next question. And the way you should practice it, don't see the lectures of Trigo. After each question, try to reattempt that after the lecture. Just by looking at the solutions, you might think they are easy, but once you try to solve the same question on your own, you might get stuck. So practice. For this particular chapter, a lot of practice is required. Okay. So this is a question: if a plus b is pi by 4, 1 plus tan a 1 plus tan b is Okay. I'll solve this question in two ways. Let's try by doing first the proper method. He's asking tan. So using this expression, I can take tan on both sides. So tan of a plus b should be tan pi by 4. Pi by 4 is 45 degree. Expand it. Tan a plus tan b upon 1 minus tan a tan b is equal to tan pi by 4 is 1. Cross multiply, so tan a plus tan b is equal to 1 minus tan a tan b. Let it be. Let's consider this as statement 1. Now let's solve what is asked in the question. He is asking us to calculate this expression. Na? So let's expand it. If I multiply this, I get 1 plus tan A plus tan B plus tan A tan B. Okay. So now I know that tan A tan B is 1 minus tan A tan B. Use this expression. I am replacing this with 1 minus tan A tan B, and there is another plus tan A tan B. These two cancels. Okay, and 1 plus 1 becomes 2. So the expression answer is 2. That's one conventional approach. Proper standard. Nothing, any sort of cheating is not done here. Now let's do the smart approach. A smart way to cheat. Again, what I told you is that if the options were given, like this approach is applicable if only options are there and the answer is a constant value. Now we know it is a constant value. Let's see if the other approach works. I told you you can take the values of take the value of the variable anything as long as the condition is true. So if I take let a as 0, then b has to be pi by 4. And let's put down the values. 1 plus tan 0 1 plus tan pi by 4. So 1 plus 0, this is 1 plus 1. This becomes nothing but 2. That's your answer also. Okay. I just put the value of a and b. I assumed it. But this can only be done in the questions which are independent of the variable as such. Means we know that the answer of this is a constant value. Then only you can do this. Okay. So for MCQs, sometimes this will work, sometimes it may not. Okay. All right. Fine. Next one. Okay. Now this is where the identities will be pretty much important here. I already gave you that identity. I told you to learn it. I told you that the variation will be very important. This particular question is just an example of it. It is given to you that cos 11 plus sin 11 about cos 11 minus sin 11 is tan something. You have to find that x. First of all, there is no tan present, so let's generate tan. I am dividing. So this is question number 7. This was 8. This is 9. Okay. So dividing numerator and denominator by cos 11 degree. If I divide it, cos will become 1, sin upon cos will become tan upon 1 minus tan 11. Okay. Now I told you to remember that identity. What is 1 plus tan x upon 1 minus tan x? That's tan pi by 4 plus x. Okay. So this is nothing but tan pi by 4 is 45 degree plus 11 degree. Okay. So this becomes tan 56 degree. So x is 56. That's your answer. Okay. So that's why sometimes these formulas are very important if they are on your tips, because the question can be manipulated anyway. Trigo is the one chapter that you will never master, no matter what. There is so much variations possible that you may get stuck. But the point is, you should cover the key concepts at least. If I'm telling you to learn an identity, learn that identity because it will be used somewhere. Okay, fine. All right, I'll end the session here. We'll continue with other identities because a lot of identities are still there. So we'll continue with other identities in the next class. All right, good day everyone. See you in the next class. Bye.